Have you ever wondered why time seems to fly when you're having fun but drags when you're bored? It's a peculiar thing, this perception of time. In one moment it's a fleeting whisper, in another, a stubborn mule. This is more than just a trick of our minds, it's a gateway into the scientific concept of time dilation, where time itself can act differently, influenced by factors like gravity and speed. The truth is, time isn't as consistent as we might think. Welcome to the fascinating realm of time dilation. Imagine if you could age slower than everyone else. Sounds like a sci-fi movie, right? But it's a real scientific concept called time dilation. Let's dive into this concept a bit. Picture a train, speeding along its tracks. On board, a passenger is calmly bouncing a ball up and down. To the passenger, the ball is moving in a simple straight line. But to an observer standing still on a platform watching the train whiz by, the ball isn't just moving up and down, it's also moving forward with the train, tracing out a kind of diagonal line in the air. Now let's replace that bouncing ball with a light beam, bouncing between two mirrors. To the passenger on the train, the light is still moving in a straight line, just like the ball. But to the stationary observer, the light is moving in a longer diagonal path. Here's the kicker, the speed of light is constant. It's the same for the passenger on the train and the observer on the platform. But if the light is traveling a longer path for the observer, it must take more time to do so. Thus, from the observer's perspective, time appears to move slower on the train. That's time dilation. But it's not just about moving trains. Time dilation also occurs due to differences in gravity. Picture a clock at the top of a tall tower and another at the base. The clock at the top, further from the gravitational pull of Earth, actually ticks faster than the one at the base. Time literally flies when you're high up. So, to wrap it all up, time dilation is the difference in the elapsed time as measured by two observers due to a relative velocity between them, or to a difference in gravitational potential between their locations. It's not just the stuff of science fiction, it's a fascinating aspect of our universe that scientists are still working to fully understand. But why does time dilation happen? It's all thanks to a man named Albert Einstein. This genius of a man introduced us to the theory of relativity, which fundamentally changed how we understand the universe. The theory is composed of two parts: special relativity and general relativity. Special relativity, which we'll focus on for now, deals with objects moving at constant speeds, particularly those approaching the speed of light. Einstein postulated that the laws of physics are the same for all non-accelerating observers, and he asserted that the speed of light in a vacuum was the same for all observers, regardless of the motion of the light source. This was a radical departure from Newtonian physics, which assumed that time and space were absolute. But here's where time dilation comes into play. If the speed of light is constant for all observers, then something has to give when an object is moving at high speeds. That something, according to Einstein, is time itself. Imagine two observers, one stationary and one moving at a high speed. If the moving observer were to shine a light, the stationary observer would see the light travel at the same speed as if he shone the light himself. But to account for the additional distance the light has to travel from the perspective of the moving observer, time must slow down for him. This is time dilation. The faster you go, the slower your time runs relative to someone who is stationary. This effect isn't noticeable in our everyday lives because the speeds we move at are a snail's pace compared to the speed of light. But as we approach light speed, the effects of time dilation become more pronounced. This means that if you could travel at near light speed, you would age slower than someone who stayed on Earth. So, according to Einstein, the faster you move, the slower you age. Now that's a mind-blowing concept, isn't it? You might think that time dilation is just a theoretical concept, but it has real-world implications. Let's take a look at our Global Positioning System, or GPS. The satellites in the GPS network are moving at high speeds and are at a high altitude. According to Einstein's theory of relativity, both of these factors, speed and altitude, affect the passage of time. The satellites' clocks tick off time a little slower than clocks on Earth due to their speed, but a bit faster due to their altitude. The net effect is that time for a GPS satellite is slightly faster than for a stationary clock on Earth. Now you might be thinking, so what? What's a tiny difference in time going to do? Here's the thing, GPS relies on incredibly precise timing. Even a minuscule discrepancy like nanoseconds can equate to a position error of many meters. So to ensure accuracy, the system has to correct for this time dilation effect. But don't take my word for it. There are experiments that have confirmed time dilation. One classic example is the Haffel-Keating experiment of the early 70s. Two atomic clocks were flown around the world, one eastward, the other westward, and compared with a reference clock that stayed put. The results were in line with the predictions of relativity. The traveling clocks experienced time dilation, each in a different way due to the direction of their journey. In a more recent experiment, researchers used two ultra-precise atomic clocks. One was placed just a foot higher than the other. And guess what? The higher clock ran slightly faster than the lower one, confirming that gravity can indeed slow down time. In conclusion, time dilation isn't a concept locked away in scientific papers or science fiction novels. It's right here, influencing our navigation systems and being confirmed by experiments. Time dilation is a part of our everyday lives, even if we're not always aware of it. So, time dilation isn't just a concept confined to the realm of science fiction, it's a part of our everyday lives. Time dilation is a fascinating concept, but it's also a mystery. There's still so much we don't understand about it. As we delve deeper into the world of physics, we find ourselves grappling with questions that challenge our perceptions of reality. Time dilation is one such enigma. It's a concept that, on the surface, seems to defy our everyday understanding of time. One of the significant unanswered questions about time dilation is, why does it occur? We know from Einstein's theory of relativity that time slows down for an object in motion compared to an object at rest. But why should motion affect the passage of time? This question remains one of the most intriguing puzzles in physics. Another mystery revolves around the relationship between time dilation and gravity. According to general relativity, gravity can bend spacetime, causing time to slow down. But how exactly does this gravitational time dilation work? And why does gravity, a force, have this effect on time, a dimension? The answers to these questions are still shrouded in mystery. Moreover, the concept of time dilation brings up philosophical questions about the nature of time itself. Is time absolute, ticking away at the same rate for everyone everywhere? Or is it relative, changing according to motion and gravity? If the latter is true, what does it mean for our perception of reality? These are just a few of the many unanswered questions about time dilation. Each one opens up a world of possibilities and challenges our understanding of the universe. They remind us that, though we've come a long way in our scientific journey, there's still so much more to discover, and that's what makes science so exciting. The more we learn, the more questions we have. Each discovery is a stepping stone leading us to deeper truths about the universe and our place in it. As we continue to delve into the mysteries of the universe, who knows what else we might discover about the nature of time itself? So there we have it, time dilation, a mind-bending concept that shows us time isn't as straightforward as we think. We've explored the intriguing query of time dilation, unraveled its complex layers, and delved into the science that underpins it. We've seen that time, as we experience it, is not a fixed, unchanging entity. Instead, it's an ever-changing, fluid construct that can stretch and shrink depending on how fast you're moving and where you're located within the gravitational field. We've discovered how time dilation is not just a theoretical concept, but a real-world phenomenon that affects everything from GPS satellites to astronauts living aboard the International Space Station. We've learned that these individuals experience time differently than those of us on Earth, albeit on a very minute scale. We've also embraced the mystery of time dilation, acknowledging that while we understand much about it, there is still much left to explore. There are still questions unanswered, theories unproven, and ideas yet to be conceived. Time dilation is a fascinating testament to the boundless curiosity and relentless pursuit of understanding that defines human nature. The next time you feel like time is flying or dragging, remember that time is a curious thing. It can stretch, it can shrink, and it's all relative. So, the next time you glance at your watch or the clock on the wall, remember, time is not just ticking away, it's dancing to the rhythm of